Hey, 8th grade geometry students, this is your teacher, Mrs. Lundgren, coming to you from my home. So I am not using a smart board. It may seem a little clumsy to you, and this is why. I am introducing lesson 9.6 tonight. This is the lesson that combines what you know about circles, what you know about area, what you know about the Pythagorean theorem, and special right triangles. And when you're done, you will find the area of sector, annulus, segment, and combinations of those. You will look through your folder tonight to find this checklist. This should look familiar. It was handed out on Thursday. And this is the tools that we will use to help us solve some of these problems. Let's look at an example so I can show you how we use this checklist. We'll look at example A. Example A, we have this tangent TA at angle A. And TA, it tells us, is 12 square root 3. So I'm going to write 12 square root 3. Oh, this is going to work great. That says 12 square root 3. And we want to find the area of the shaded region. So I go over here to my tool list. It says, do I need an angle measure? No, I want area. Side length? No, I want area. And I'm looking at the area of a sector. So I can see right now that this is the formula I want. And that formula is A over 360. It's trying to write in straight lines. Doesn't work so well when you try to write the number 3 times pi radius square. There we go. So now I need some things in my formula. I need little a, which is the angle of the sector. And I know we can find this angle because it's part of a triangle. Well, I need at least 2 angles to find the third, so I wish I could find angle A. And I can't, because TA is a tangent, and right here it says that every tangent meets its radius at 90 degrees. So at the point of tangency, that's 90. That means that leaves 60 degrees for this angle. So the shaded region has 300 degrees. I can erase A, go back up and get an eraser, erase A, and attempt to write the number 300. That was good. 300 where it says angle. That's the shaded part I want. Now I'm still missing a radius, and a radius is a length. So we're going to check to see which of these will be helpful. Do I have a 45, 45, 90 triangle? No. Do I have a 30, 60, 90? Yes, 30, 60, 90. So I'm going to use the rules about the 30, 60, 90, the conjecture. And the conjecture says that the short side times square root 3 will give you that long leg. Well, here's the long leg. It's 12 square root 3. So I can work backwards to find the short leg. The short leg will be 12. That short leg happens to be my radius. So I know that I can erase r squared. I can replace the r with the number 12. And I now can solve theoretically for area. I know that 300 over 360 is 5/6. Let's try typing 5/6 perhaps. That'll save us some time. 5 sixths, and we'll put a line underneath the 5. So I have 5/6 pi times 12 squared. 12 squared is 144. So I will rewrite 144 right here. And I still need pi. Perhaps I should capture pi, and then I do not have to try to redraw pi. And there's pi. I'll put it down here. So I can solve this. I know that 6 goes into 144, and that would be 24 times. I've got 5 times 24. That'll give me 120 times pi. So my answer will be 120 pi, and my label is centimeters square. So there's one example of how to use the checklist to solve for an area. Let's look at a second example. Read the problem to yourself while I erase what I've written on my checklist. So I'm looking for the length. In order to find a length, it says I can use 45, 45, 90, 30, 60, 90, or the Pythagorean theorem. I don't even have a triangle. But down here it says when all else fails, draw an auxiliary line to make a triangle. So I'm going to make a triangle. I'm going to draw in OB, and I'm going to draw the radius of the smaller circle from O to A, or from O to the line AB. And whenever you draw that length, that will be a perpendicular. So I know this is a 90 degree. I don't know it's 30, 60, 90. I don't know it's 45, 45, 90. But let's talk about what lengths we know. We know that this length is 6 meters. That's the distance from here to here. I'm going to mark that as 6. I know the radius of the inner circle is 24 meters. So this length is 24 meters. Now I know two side lengths. I don't know the whole thing here. I know this is 6. Oh, wait a minute. But I do know the distance from O to the edge of the inner circle. That's 24. So this entire side OB is 24 plus 6. In other words, that's 30. And using the Pythagorean theorem, I know this is the hypotenuse. So this will be 30 squared equal to A squared, which is 24, plus B squared. B squared in this triangle is the length here. We solve that. This is 900. We all know that 24 squared is 576. That's a 6. And whatever we get here will equal B squared. Borrow. Make that an 8. This leaves me with 4. 9 minus 7 is 2. 8 minus 5 is 3. Square root of 324 is 18. So the half the distance of AB is 18. This part is 18. If I double it, I find the length of AB. Twice 18 is 36. That is, oh, that's meters. Not meters square, it's a length. That is 2 examples of how to use the checklist. We will solve more problems like this in class together on Monday, and then you will solve a few at home on Monday night. Thanks for watching.